Okay, so today what I'll talk about is basically some some of the issues around the layer 2 ecosystem and especially the user experience in the layer 2 ecosystem as I see it today, and some of the things that we can do to like really reduce a lot of the downsides of having this world where we have a lot of different layer 2 projects and sometimes they don't talk to each other very well, and move toward in Ethereum where we get the benefits of all of this independent innovation, but we also have enough layers of standardization that it still feels like a single unified ecosystem at the same time, right? So the way that I think about the high-level goal is basically that being a user inside of the greater Ethereum verse, so including L1, including Optimism, including Arbitrum, including everything, should not feel like you're jumping between 34 blockchains. It should feel like you're using Ethereum. So one other way that I think about this is that I think the goal that we should try to aim toward is we should aim toward a 2015 era Ethereum experience with 2015 era fees, right? So you just have, it looks like you just have one chain, you're just sending things on chain, you have an address, people can send things between each other, and the fees are extremely cheap, but at the same time, with 2029 era quality of user experience and scalability. So let's look at cross-layer 2 asset movements for a bit, right? So above here, I have a screenshot of what it looks like for me to do a deposit to Polymarket, right? So what happens here is it says there's an option to deposit USDC, and in order to deposit USDC, you have to make sure to send USDC to this one particular address. And like, it has to be Polygon. It cannot be Polygon ZK EVM. See, Polygon and Polygon ZK EVM are totally different, okay? Got it? And you have to send ETH to Polygon. And then if you send ETH to that address on the wrong chain, then your money is stuck, right? So this is where we are right now. Where I want Ethereum user experience to be is something like what I have below here, right? So basically, the way that it should look like is they provide an address, and if you want to deposit, you just have to take that address, copy it, paste it in your wallet, click send, and that's it, right? You should, as a user, you should not even have to really worry about or think about the concept that there are different networks. You basically just like you would have an address, and then you send your coins to that address, and you're done, right? So one question that we can start from is basically, what are the technologies, what are the changes, what are the standards that we need to actually make depositing to Polymarket look like the thing on the bottom instead of looking like the thing on the top? So this is ERC3770, right? This is a standard for how addresses can work in a way that makes sense in a cross-layer 2 ecosystem, right? So today, an address is just 0x, and then you have your 20 bytes, and like that's your address inside of some network, right? Now, if I give you my address, you don't know whether I'm accepting funds on mainnet, on Optimism, on Arbitrum, somewhere else, right? Like actually, you know, I could want you to send funds to me on Optimism, but you could instead send me funds on Arbitrum, and like mistakes could happen. The way that ERC3770 works is the chain is part of the address, right? So in the example here, if you want to send to my address on Optimism, it would look like OP colon 0xD8DA blah, 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 right? So chain is part of the address, right? So the core idea is basically that the address should contain all of the information that someone needs to know what's to do if they need to send you money or if they need to delegate some kind of authority to you, right? So the function that an address had in the world back in 2015 when everything was on layer 1, that's the same function that an address should have in 2024 when we have all of these different layer 2s. So what this means is the network needs to become part of the address, right? And in my example here, that's basically what I have, right? I have polygon colon 0xf blah, blah, blah. And then if you take an address that contains polygon colon 0x blah, 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 and you put that into your wallet immediately understands that this is a request to send coins to Polygon, right? And so it doesn't try to send coins anywhere else. It specifically tries to do something to make sure that coins on the Polygon network get sent to that address. So the first part of this is just defining the address standard, right? This is something that Safe already uses. This is something that more and more wallets are already starting to use today. Another standard, which is also important, is ERC7683, right? So ERC7683, what it does is it actually does cross-layer 2 asset transfers, and in particular, it does them through liquidity providers, basically through a decentralized exchange mechanism, in such a way that if I initiate a send on Optimism to Arbitrum, then I send the transaction, it gets included on the Optimism chain, and the destination address should get the payment on Arbitrum generally within 1 or 2 slots, right? Even though Optimism natively has a 7-day withdrawal window, and Arbitrum has like several minute deposit window, you rely on liquidity providers to provide the capital immediately, and then once they're able to prove that they transferred those funds to you, they can claim the funds on the Optimism side from you, right? So basically just using a general this purpose cross-layer 2 decentralized exchange network and having this actually directly incorporated into wallets, so that if you want to send coins from one network to another, it just automatically directly uses this, right? Like the concept of sending coins and the concept of bridging should not be 2 separate operations. They are the exact same operation from the user's point of view, right? And the wallet should just handle doing a send if it's on the same network and doing a bridging operation if it's on different networks. Now, that's a short-term future. Now, let's talk about science fiction a little bit. Here is a longer-term future, right? So imagine a world 5 or 10 years from now, and everything is a ZK rollup, and everything uses ZK prover technology that confirms within 1 single slot. This is starting to be actually possible, right? It's theoretically, this is completely possible, but practically, we actually have ZK provers that are able to prove, right now, average Ethereum blocks in about 15 seconds, right? Now, this does take a lot of GPUs, right? This does involve parallelization, but the latency is already decreasing massively, right? And there's no theoretical reason why the latency needs to be longer than maybe 4 seconds. And so if you have ZK rollups that are all confirming to Ethereum in each and every slot, then there's actually a way that you can do all of this cross-layer 2 trading without even needing liquidity providers, right? And this is an interesting strategy that, I know some people are starting to look into. And so, Justin has been looking into this. Alex Glowowski from Matter Labs has been looking into similar things, a lot of people, right? And, basic idea here is, so let's take a simple case, right? Let's look at commonly traded assets. So let's look at, for example, ETH and wrapped Doge moving from, let's say in this case, from scroll to base, right? So fairly common networks, fairly common assets. So what happens is that on the source chain, so in this case Arbitrum, right? Basically you have a lot of different transactions, and you're going to have a lot of transactions that are sending coins cross-chain, and they're sending them to different users, but they're sending them to the same network, right? And so over here, from a user point of view, you have someone sending 5 ETH to Bob, someone sending 25 ETH to David, someone sending 20 ETH to Fred, But from a network-to-network point of view, these are all transfers from Arbitrum to Scroll, and so you batch them, and as part of the block, you just directly make one transfer that immediately transfers the coins from Arbitrum into Scroll. So this is if you have commonly traded assets, right? Now, one big question is, well, what about rarely traded assets, right? What about coins that are extremely rare, coins that only have a few people using them, or even NFTs, right? One of the big challenges with 7683 is that it only works well for commonly traded assets. It does not work at all for NFTs because there's only one copy of each NFT, right? Like you cannot use a liquidity provider to like give you some shadow copy of like Vitalik.eth, right? Like liquidity providers can't just like clone Vitalik.eth and then front a copy and for me and then like claim that copy back 7 days from now. So for rarely traded assets, we use another trick, which is we can make a specialized mini ZK rollup which performs only the task of managing asset transfers, right? So you basically have a mini ZK rollup whose role it is to accept a more complicated list of transfers, basically a list of all kinds of different assets, ERC20s, ERC721s, that are being transferred from one L2 to another L2, and then it has one block and it's also an L2, and so you have this entire big set of transfers that gets processed on L2, and L1 only sees the updated state root of Arbitrum, and it also sees the updated state root of this asset layer 2, and so you're still only putting a little bit of information and doing a little bit of computation directly on layer 1, right? So this is a possible future, like a possible long-term future of how asset movements might work without relying on any kind of liquidity provider infrastructure in the far future. Now, this still requires a lot of technology, right? This still requires very robust ZK EVMs that can provide proofs in one slot. But like I think this is where we're going to get to eventually. Now, cross-chain account abstraction, right? So, we talk, lots of people are using Safe, right? So who here uses Safe? Good. Lots of people using Safe. Now, one challenge with Safe is what happens when you have assets across many different chains, and at the same time, you need to sometimes upgrade your wallet, right? So like, for example, you might want to change your key. If it's a company, maybe remove one key holder, add one key holder. If it's a single user, maybe you don't trust some key anymore, you want to switch to some new key, you want to upgrade a hardware wallet, like anything. The challenge is, if you have your wallet on 20 different L2s, then how do you actually do that upgrading at the same time? So the short-term solution is to make the upgrade be a message that can just get automatically replayed across chains, right? And this is something that people are already starting to do. The long-term solution is this approach called key store wallets, where you have the record of what the keys to an account are and what is the logic that verifies an account in one place. And then you have assets in many different places. And you have a safe that's in many different places, and that safe can read into the key store. This is easiest to implement if the key store is on L1, right? So on L1, you can have your account, you can update your account, and then L2s can read into L1 every time you make a transaction. So this is something that Optimism already, I believe, supports. I know Scroll is looking into supporting it, like basically the ability for L2s to read L1. If you have this, then supporting things like key store wallets becomes much easier. Gas payments. So today, you need to have ETH on chain A in order to send transactions on chain A. One thing that will become possible tomorrow is you pay ETH on chain A, and then you automatically pay, like basically create an open auction for a bundler to send a transaction on chain B on your behalf. These are things that are like starting to be already possible, right? But these are all things that we can absolutely do using decentralized networks, right? In a way that does not have any dependency on specific centralized actors. Now, you could have people that are professionals that specialize in doing these operations, but if one of them disappears, another one would be able to immediately come in and take their place. Light client support. So today, we actually are starting to have light clients that can kind of verify L1. So there's a project from Noah Citron, A16Z Crypto, called Helios. And Helios is a light client for Ethereum. So it actually verifies at least part of Ethereum consensus. And so if you're using Helios to access the Ethereum chain, then you're not trusting Infura to give you state roots, right? You're actually verifying signatures, and you're verifying that the chain that you're following actually is the chain that the majority of the Ethereum stake is supporting. We have this for layer 1, kind of. Like, it's still early stage software. It's not yet incorporated into the major browser wallets. It should be, but it will get there. But we have nothing for L2, right? And I think we need to always keep in mind, right, as we move from layer 1 to L2, all of the guarantees that we wanted from Ethereum L1, we need to make sure that they apply to layer 2 as well. So the future is we need to have light clients also support layer 2. The good news is this is kind of easy, right? Actually, Helios already does the hard part, which is verifying consensus. And so you have the header chain, right? You have the chain of like basically the most core parts of the Ethereum blocks. Once you have the header chain, you can use Merkle branches and you can verify any particular thing in the Ethereum state. Now, once you can verify things in the Ethereum state, then if you have a based rollup, right? So this is the example on the left, right? Tycho, a based rollup. Then it actually has a contract that contains a state root, and then you use another Merkle branch, and then you can verify any object inside of the Tycho state. If you have a rollup that's not based, then you have a contract. That contract stores what the current signers are of L2 blocks, and then you basically accept anything that's signed by that particular set of signatures. So somewhat more indirect approach, but this is what you need to do to have like best in class, like as trustless as possible access to an L2. So this requires some software work. This also requires some standardization. So in particular, a chain config should also have some kind of pointer to the code that actually does L2 light client verification. So I recommend like we basically just do this the same way that the CCIP ERC does it, right? Basically, you just have an on-chain contract that has a function that does the verification, but there are several different ways to do this. Proof aggregation. So there's two big bottlenecks that are preventing us from having ZK rollups that submit to Ethereum every slot. One of them is prover latency, right? Right now, for most of the production systems, proving blocks takes maybe 10 minutes, maybe 20 minutes. It takes some amount of time. The other problem is that putting a proof on Ethereum costs gas, right? It costs quite a lot of gas. For a very simple proof, about 300,000. For something like a Stark from Starkware, maybe 2 or 3 million. So these are costs that they do not want to have to pay in every single slot. And so a natural solution here is to have an Ethereum-wide open infrastructure that does proof aggregation, right? Basically, L2s can submit their proofs. Instead of submitting them directly on-chain, they can submit them to an open network. And then when they submit them to an open network, you can have anyone that's able to create a bundle, and the bundle generates a proof of the proofs. So it generates one Stark that proves that all of these other proofs that are specific to the layer 2s exist. It generates that one proof, and then it publishes that one proof on-chain, and that automatically updates the state for all of the different L2s. So if you do this, then L2s would be able to publish to Ethereum every slot, and it actually would have a lot of gas savings. Application layer stuff. So oracles. This is one thing that's currently not very efficiently designed. It could be more efficiently designed. Basically, if you have L1 SLOad or L1 calling, then you could have Oracle data live only on L1, and then all of the L2s can just call into it. Or you could try to use a pull architecture instead of a push architecture for oracles. ENS needs to move to L2. They have plans for that. They're executing on them. ENS supporting users having different addresses on different layer 2s. So these are just like some of the big examples, right, of things that we need to have if we want the Ethereum layer 2 ecosystem to have the same kinds of properties that we have been expecting the Ethereum ecosystem to have all along, even back in 2015, when all that existed was layer 1, right? The transition to layer 2 is there to enable scale without sacrificing decentralization. And we need to do all of this work. We need to actually work hard to make sure that we actually do not sacrifice decentralization. So what do we get if all of the ideas that I just talked about are implemented? Let's talk about the user's experience. If you're a user and you need to send assets, could be ETH, could be USDC, could be an NFT, then all you need to do is put an address into the to field and then click send. Basically, you would need to do just the thing that you were doing back in 2017 when everything was on one network. Except with all of these standards, it would actually work regardless of which L2 you're sending from and regardless of which L2 you're sending to. The user experience to upgrade your wallet. You do it once, and you do it in one place, and it immediately has an effect everywhere. The user experience to pay gas, right? Now, I know there are a lot of people that have a lot of different ideas for how to support different users, even users that do not have any ETH, but I think at the very least, if you do have ETH, you should be able to click send and transaction fees should be able to get paid. You should not have to worry about making sure that you have ETH in all of the right layer 2s at the same time, right? There should be things that you can do that work entirely in the background so that if you have ETH, then you can click send, send a transaction, and everything that you want to happen actually does happen. The user experience to verify the chain. So the user verifying the chain should be fully secure, should be trustless. You should not need to trust an RPC provider. You should not need to trust centralized infrastructure. Even if you use centralized infrastructure in order to get information about the chain quickly, you should not have to trust it. And I think this is something that actually is possible to achieve. And the time that it takes for transactions to finish should only be one slot, right? 12 seconds. So basically, like, we can get all of the same benefits that we actually already had when Ethereum was one chain, when it was just a layer 1. But at the same time, we can have an ecosystem where we have those benefits, but also we have much more scale. We have like thousands of times more scale than we had before because of the layer 2 ecosystem. And at the same time, we have this ability for people to have many different kinds of layer 2s that try different things, that take different trade-offs, that experiment with different virtual machines, experiment with different kinds of centralization and decentralization. And so we get the benefit of experimentation at the same time, right? So we have 1,000 flowers blooming, and at the same time, we have standardization, and everything still feels like you're sending ETH, you're sending assets, you're participating in DAOs, doing all of your operations within one single great Ethereum ecosystem. So this is the goal, and I hope that we can work hard to get there. Thank you.